this is the horizontal axis, and here is the paper roll whose area is into the axis. No, not actually area, but this face here, as you can see, is lying on the screen, and the axis we are talking about is into the screen. Okay, so that is what the first statement states. Paper is drawn at constant speed v. Okay, the thickness of paper is b, and r is instantaneous radius of roll. B is very small than r, such that the time taken to complete one rotation can be taken as 2 pi r upon v approximately. The angular acceleration of the paper roll is given by alpha is equal to b into v to the power a upon 2 pi r to the power c. Then find a plus c. Now let us see the solution of the problem. Now how is this calculated? This is very easy. So for that we consider an instance where the radius is r and the length, or we can say the radius of each and every point from the center, or the distance of each and every peripheral point is same. It's not different. Now you would be wondering, what is the case when the different points at periphery will have different distance from the center. Okay, so let me elaborate the example in which the points at periphery will have different distance. Okay, different distance. Like for example, this is the paper roll, and we have just plugged some of the paper out over here. Now, since we removed some of the paper over here, now this is going to move here, and since this is going to move here, some of the layer that laid on here is getting removed. Okay, sorry, not this layer. Okay, I am talking about this layer actually. Now this part, okay, I am talking, let me mark the part, okay, about which I am talking. I am talking about this part. Okay, this part, once we pull this paper, this part is going to go here. Okay, this part I was talking, this part only. This part will go here because this is B, and so omega will be this in this direction, that is yes, this clockwise. So this part will go here, but now the part over here will have the same radius. Okay, but the part that has just gone here, okay, the part from here which have just gone here, sorry, okay, the part which was first here and which has gone here will have a layer removed, but the part which haven't gone through here, haven't rotated through this point, will have some extra paper over it which haven't been removed, and therefore the distance of the points at periphery will be different at different regions. Okay, but once the whole roll completes one whole rotation, what will happen? The whole layer will be removed. The point which was at this instant, after one complete rotation, it will again come at this. So somehow the whole layer gets removed. So the whole layer will get removed because this point will again come over here. So the points which were remain the points which were remain for the layer to be removed also will get removed, the layer. Like for example, let me clear what I am talking. Okay, now for example, this was a point. Okay, let me take some another color. Okay, let's assume that this was a point, and now the layer got removed from here. So this point went here. Now when this will complete the whole rotation, all these parts in front of it, okay, all these parts in front of it will have some extra layer, because once this part gets layer removed, the particles or the part behind, or the region behind it will also get the layer removed. So somehow that region is coming with it, okay, in the in the clockwise direction. This is clockwise direction, you all know. So but the region that is in the front of this uh, point will have that extra layer that is yet to be removed. But when this goes and comes again at the initial point, that layer gets removed, and again the radius or the distance from the center of each point at periphery will be same. So we are only taking the condition when only yes when the when the radius is equal. So we are not going to use the formula to calculate alpha is equal to d omega by dt, because the radius is varying. So we are going to use formula omega delta omega upon delta t, because for knowing d omega upon dt we must have proper idea about omega at any instance. But since the radius is not feasible to calculate at any instant, we are taking omega at those instance when the rotation, one complete rotation take place or two complete rotation take place, because at that time only the radius is somehow equal at each and every point, and hence it's more easily we are able to calculate omega. Therefore, rather than using formula of d omega by dt, we use formula delta omega upon delta t. Now how we calculated this time? Now obviously when we complete one complete rotation, the radius will be r upon b, as I cleared it previously. And first the radius was r. So what was omega? V upon r, because this is velocity and radius is r. V upon r, and here V upon r. And so somehow b being too small, omega remains the same. And since omega remains the same, we can say what is time required is equal to angle covered upon omega. And what is angle covered in one complete rotation? It's 2 pi. And omega is v by r. It remains same. Now obviously we are taking this approximation only to calculate time, or else if we take it for all other instances, the angular acceleration will be 0. So as I cleared that we are going to use formula of alpha is equal to delta omega upon delta t. So we are going to take delta t as time required for one complete rotation. So our work is done. So this is the omega before one complete rotation. This is omega after one complete rotation. This then the subtraction of this both will be delta omega after one complete rotation, and this is the time required for it, approximate time obviously. And then by just calculating, we come across this. Here you can see. And now since b is very small, we can say that r minus b is nearly equal to r. Oh, sorry, nearly equal to r. Again equating it equal to r. So again we can replace r minus b with r. So our answer will be v square upon 2 pi r cube. And so we have got a and we have got c. Actually this is c, not b. This is also c. So a plus c will be 2 plus 3 5. Thank you.